How's it going? So today we are going to explain this problem, division 2, problem D, and its rating is 1800, right? It's posted by Rahul, right? And as always, we are going to explain this problem by introduce the example here. So we got four numbers in the input, right? So the first two numbers, we can sum up it, and 2 plus 1 equals 3. So that we got three numbers, right? These numbers are either 0 or 1, right? And we are going to put 0 and 1 in this array, right? And we got two zeros, right? The first number is the number of zeros. The second number is the number of ones, right? We got two zeros and a one. And the third number is a constraint to place zeros and ones. The constraint is that the maximum number of consecutive zeros is 1. So we at most have one consecutive zeros here. So if we make an array like this, then we got two consecutive zeros here. So this array doesn't satisfy this constraint. So this array is not valid, right? And the fourth number is the maximum number of ones in consecutive ones in the array, right? For example, uh, actually, we only have one in this array, so it can never exceed 10. So we don't have a constraint on the placement of ones here, right? And the output is the number of valid placement. So for the first example, we only have this placement, right? Just have one array that satisfy all these constraints. So let's try another array. We got 1 at the first place and 0, 0 at the second and the third place. This guy has two consecutive zeros in a row, so it doesn't satisfy the constraint, so it's invalid. So this is the only valid array, right? So let's take a look at the second example. So what are the valid arrays here? We have 5 valid array, right? So because we need to put two zeros in the array, two zeros, right? And put three ones in the array, three ones in the array, right? And the maximum number of consecutive zeros is 1, right? 1 0, 1 0, 1 0, 1 0. And the maximum number of consecutive ones is 2, right? For example, we got 1, we got 1 consecutive one here, 2 consecutive ones here, good. 2 consecutive one here, 1 consecutive one here, good, right? All good, right? So in total, we got 5 different arrays that satisfy all these constraints, right? So how do we find the number of valid arrays? To answer this question, we usually use dynamic programming, right? So the most important part of dynamic programming is to find the definition of the states, right? And then based on the states, we find out the formula to calculate all those states, right? And what is the state here? So it's a four-dimensional state. And if we, the definition of the state is that if we use total I numbers of I numbers including j zeros, right? For example, in this case, f 3 0, I mean 3 2, right? That means we use totally three numbers, right? Including j zeros. It means two zeros, right? For example, we got two zeros here. And it also means we will have I minus j number of ones here, right? And the last L soldiers are K in a row. It means the last soldier of this guy is 0, right? That means the last one soldier are 0, right? And uh, this guy is the number of arrays that satisfy. We use I number including j zeros, and the last L soldiers are K in a row, right? These are the constraints, and this value is the number of valid arrays, right? So for example, this guy means we use total three number. We use three numbers, and two of them are zeros, and the last one number is 0, right? So how many arrays that is valid, and that is valid for all these constraints? This is the number of possibilities, right? So how do we deduce all these values? So this is the way we calculate all those f's, right? So let's say we already calculated fi, j, k, l. This is a known value, right? And we assume that this is a known value, and that means we got I numbers, right? I numbers. Actually, let's make some more. Um, 1, 2, 3, 4. Right? So let's say we have I numbers, and we got j zeros. The number of zeros in those valid arrays are j, right? And we got last L, L, uh, the last L numbers are K, right? So we already know the number of possibilities of this kind of um, array, right? So it satisfies four constraints. One is there are I numbers. One is that there are j zeros. And one is that the last L numbers are the same and they are k, right? And how can we deduct? How can we put a number here, right? And add these possibilities to this I minus 1 state, right? We want to calculate I minus 1 from I, right? So there are two additional possibility. So the first is we put 0 here, and the second is we put 1 here, right? There is all of those possibilities that we can explore in the I plus 1's position, right? So first, let's discuss when we put a 0 here. In this case, if k equals 0, right? So in this case, k equals 0. So we have L zeros in the end of this array, right? Then fi plus 1, it means this state, right? It has j plus 1 zeros because we add one more zeros here. So in total, we got j plus 1 zeros, right? And the last x plus 1, actually here is L plus 1, right? The last L plus 1 numbers are 0, right? So we need to add all these possibilities into this state, right? So um, up. So if we already calculated this state, then we can add all the we can add the value of this state into the value of this state, right? That's the way we used to calculate all of the states in the problem, right? And what if k equals to 1? That means we got L1 L1s in the end of the array, right? Then the state's first dimension change to I plus 1, right? Because we put a 1 here. And the number of zeros uh, the number of zeros actually no I mean k equals to 1, but we still put a 0 here because we still exploring the possibilities of 0 here, right? So we still put a 0 here. Then the state changes into this state, right? I becomes I plus 1 because we have one more number, and j becomes j plus 1 because we have one more zero, right? So we have j plus 1 zeros, and the last one number is 0, right? The last one number is 0, right? So this kind, we need to add the value into this kind of possibilities, right? And I guess that's all we need to add when we put a 0 after this kind of states, right? And we can move on. So what if we put a 1 after this state? What happened? Let's see. So we remove 0 here and add a 1 here, right? So what if we put a 1 here? Then if k equals to 0, that means these L numbers are 0, right? And um, the state transferred to I plus 1. This is obvious because we have one more number. And j, still j, right? Because we put a 1 here, so the number of zeros are the same, right? And the last one number, the last one number is 1, right? And we add this value into this state, right? And then what if the last L plus 1 numbers, what if the last place, what if k equals to 1? So the last L numbers are 1, right? So the state transfer into this one, right? We got I plus 1 numbers, and the number of zeros are still j, and the last L plus 1 numbers are 1, right? So we add the value into this state, right? So we calculate the state from I to n, from 0 to n, right? N equals to the sum of these two numbers, right? And the initial state is that we have 0 number, and we have 0 zeros, and the last 0 numbers are 0, right? And this kind of array, the number of this kind of array is 1, just one possibility. This is the initial state, right? And we can calculate f1, etc. from this state, right? And after we calculated all the f1 states, we can use them to calculate f2 state, right? Because after we add all these f1 states into all these f1 I plus 1 states, we first calculate the fi states, right? After all these fi states are calculated, we can move on to fi plus 1 states, right? And uh, that is our way to solve this problem. So let's look at the code. The code is here, right? Here's the code. First, we are going to read n0 means the number of 0, n1 means the number of 1, and the maximal consecutive numbers are these two, all right? And then this is the initial state, and we record the final answer in this variable, right? And then we explore explore the I from 0 to um, the total number of soldiers, right? And this guy is make sure that we don't use more zeros than we need to, right? So um, let's say we have um, I numbers, and the number of zeros inside it shouldn't exceed the number of numbers, which is I, right? And it shouldn't also it also shouldn't exceed the number of total zeros. That is explained here, right? And we need to use both 0 and 1s here, right? And the L is from 0 to mk, right? Because the number of consecutive um, the number of consecutive same numbers cannot exceed mk, right? We are going to use k here, so it cannot exceed mk, right? And if this value equals 0, it means it is not possible to achieve this state. So no array is valid. No, this kind of array is valid, right? So in this case, we continue, right? And if I equals to the total number of n's, we need to update the answer, right? Because this answer records the total number of valid arrays. So we need to add this state into the answer, right? And this part is where we either put 0 at the position I plus 1, or we put a 1 at the position I plus 1, right? This guy explores these two possibilities. And this guy here, JJ here, is to find out the number of zeros in the current state, right? So if the number we are going to use at the position I plus 1 is 0, then we add the JJ by 1, right? And if C equals 0, it means we're going to put a 0 here. And JJ bigger than N0. It means the number of zeros we are using is bigger than the number of zeros that the problem allow us. then we continue, because in this case, the constraints are not satisfied, so we continue, right? And this is the same idea to check the number of ones is still valid, right? If it is bigger than n1, then it's not valid, right? And this guy checks k. So this guy is checking the number we are used at the I plus 1 is equal to the last number of last states. So if um, it equals, then we are going to check. So L plus 1 is less than MC. This guy is still checking that if we have the valid states, right? And then if all those constraints are satisfied, we are going to add this possibility into the next state, right? And this guy is also the same, right? So in the end, we are going to output the final answer, right? So I guess that's it for today. Thank you for watching.